Hi, this is Julie Harland, and I'm your math gal. Please visit my website at yourmathgal.com where you could search for any of my videos organized by topic. This is an introduction to age problems, and on this video we solve the following word problem. All right, this is an introduction to age problems and the idea behind them. Let's just say that Mary gave birth to Bob in 2000 when Mary was 24 years old. So I have a chart here. What year it is, what Bob's age is, and what Mary's age is in that year. So notice in 2000, Bob's born, so he's 0, right? And Mary's 24. The next year, he's 1, she's 25. The next year, he's 2, she's 26, etc. I've gone up, let's say up to the year 2006. So the first thing I want you to notice is that when he's 1 year old, she's 25 times as old as he, right? She's lived 25 times as long as Bob's lived. But 1 year later, look at, he's 2, she's 26. She's lived 13 times as long, not quite as long, right? So the interesting thing is, she's always 24 years older than he is. Do you see that? Like, when he's 2, she's 26. When he's 3, she's 27. She's always 24 years older than Bob, correct? But, when you compare how long each of them has lived, that's very different. For instance, when he is 3 and she's 27, now she's only lived 9 times as long. When he's 4 and she's 28, she's lived 7 times as long. And when he is 6 and she's 30, she's lived 5 times as long. I want you to think about it. How old do you think he will be when she's lived twice as long? In other words, he would be half her age. Can you figure that out? That actually happens when he is the same age she was when he was born. So when she's 24 and when he's 24 and she's 28. But for now, I'm just going to write something down here on the side here. So this is what we just had, that, in 2001, she's 25 times as old, 13 times as old, 9 times as old. Even though that's true, she still is always going to be older than him, right? By a full 24 years. A lot of people have trouble just with that basic concept, so I wanted to bring that forth. And for instance, in what year will this happen? I think 2024. He will be 24. She will be 48. And she at that time will be twice as old. He'll be half her age, right? Okay. He will never catch up to her. But after this, she will never be twice as old as him again. For instance, if you go through, it looks like he's getting close to her age, but not exactly. Whoops. Pushed the wrong thing. So let's say we take another year. Let's say we project all the way up to the year 2070. He'll be 70, she's 94. They're kind of both getting up there at that time. He's still younger, but it's not even twice as old anymore, right? So that's the first thing I want you to think about with age problems. Now here's another way of thinking about it. Bob's age now, let's just say, is B, and Mary's age is M. Okay? Then in 2 years, how old will he be? Well, think about how old you would be in 2 years. You would be 2 years older, so what would you do to your age? You would add 2 years to it. So whatever Mary's age is, she would add 2 years to it. Okay? In 2 years. What about 3 years ago? So we have to look at the column now, right? So I don't know how old they are right now. But 3 years ago, Bob would have been 3 years younger. We would have subtracted 3, right? He'd be 3 years younger. And whatever Mary is right now, we would subtract 3. This is the key idea in age problems. Usually you're going to have a column for how old they are now, and then maybe something for in 2 years or in 5 years or maybe in X years. Maybe you don't know how many years down the line you're looking for that, or a certain amount of years ago. Now in this case, we actually know that however old Bob is, Mary is always really 24 years older, right? That's always going to be the truth because she was born 24 years earlier, right? She was 24 when she had him. So if Bob's 24, she's 24 years older. So if Bob's age in 2 years is B plus 2, Mary's age would be what? You would add 2 years to whatever age she is now. So if she's B plus 24, whatever year this happens to be, she would be B plus 26 in 2 years from now. And 3 years ago, how old would she be? We would have to subtract 3 from how old she is right now, which would be B plus 21, etc. So these are some key ideas that you're going to be using to do an age problem. All right, here's an age problem. Tim is 9 years old, and his great-grandma, who he calls Nana, is 84 years old. In how many years will Nana be 4 times as old as Tim? Notice right now, let's see, how many times as old is she than Tim? Well, if she was 9 times as old, she'd be 81. So she's more than 9 times as old, right? But she's not quite 10 times as old. 10 times as old, she'd already be 90. So we know that like as time goes on, they kind of get closer, and they're always, a certain number of years apart, but their relative age, like it's at a certain point in time, she's actually would only be twice as old, if they were still living, etc. All right, so let's make up a chart for what's going on here, and let's see, what are we looking for? We're looking to see in how many years will she be 4 times as old. So we don't know how many years that's going to be. That's where our variable is going to come in. So let's start off with, and I think I'm going to put these a little bit closer together so I have more space. A little chart where we talk about Tim's age and Nana's age. Okay, so we're talking about the age of Tim, and we're talking about the age of Nana. All right, and it's different in certain years, right? So right now, what does it say? It says right now, Tim is what? 9 years old. And right now, Nana is 84 years old. So in this example, we know exactly how old each of them is. And what it's asking for, it's something about in so many years from now. We're trying to figure out how many years from now. So let's say in X years. There's our variable. Now, how old would you be in X years? In 1 year, you would add 1 year to your age. In 2 years, you would add 2 years to your age. So in X years, you would add X years to your age. So in X years, Tim will be 9 plus X. Nana will be 84 plus X. All right. Now, what about what happens in that many years? At that time, Nana will be 4 times as old as Tim. So they're basically saying Nana's age in X years. Let me move that over here. They're saying that should be the same thing as 4 times whatever Tim's age would be. Right, that's what this is saying. In other words, she's older than him, right? You have to take Tim's age and multiply it by 4. All right, what is Nana's age in X years? I have to look and see from this chart, it tells me how old she is in X years. She is 84 plus X. So that's Nana's age in X years. And that's the same thing as 4 times whatever Tim's age will be at that time. And how old will Tim be in X years? 9 plus X. And that's our equation. All right. So let's solve it. 84 plus x, let's distribute the 4, equals 36 plus 4x. So I have to get the variables on one side and constants on the other. Since 4x is on the right and that's bigger than x, I'm going to leave the variables on the right-hand side. So I'm going to subtract x from both sides. So I'll have the x's on the right side of the equation, and I'm going to go ahead and subtract 36 from both sides, so I'll have the constants on the left. So I think that gives me 48 on the left, 84 minus 36, 48, equals 4x minus 1x, right, is 3x. So all we have to do is, whoops, that always happens to me, divide both sides by 3. So I'm going to get x is 16. Or you could write x equals 16. Okay, now we have to remember what x stood for. So let's go back up. In how many years? In fact, that was their question. In how many years will Nana be 4 times as old as Tim? So it looks like the answer is in 16 years. But we definitely want to make sure this is correct. So now we're going to go back and look up to the words and see if this all checks out given the original information. All right, so this was the original problem. We think it's in 16 years. Let's check it out. We know right now that Tim is 9 and Nana is 84. How old would each of them be in 16 years? In 16 years, if he's 9 now, he will be 25, right? We would add 16. And Nana in 16 years will be 100. So now look at it. If Tim's 25 and Nana's 100, is she 4 times as old as Tim? Yes. So that means our answer is correct. It'll be in 16 years. Please visit my website at yourmathgal.com where you can view all of my videos which are organized by topic.